All right, thank you. You had so many questions on the marketing section. I don't know what's going to happen to me now. All right, my job here is to set you actually on how this technology works. Okay, so I forgot to introduce myself. My name is Alessandro Barbieri. At Pluribus, I'm responsible for product management of the platform. So what I want to cover today is a little bit how this technology works and demystify it a little bit, because in the end, it's actually fairly simple, right? And I have two sections here. One is a technology overview of the fabric itself. What is this fabric? How really does it work? And then I want to cover in the second section some of the advanced services we can provide and how we can help to simplify, automate an environment, which is a traditional leaf spine environment, for example. So first off, I'm going to spend time on the bowels, if you will, of the fabric, and then we look at how it can be applied to solve problems such as microsegmentation, automation, and how also we integrate in a VMware environment. So we spent significant energy even in the previous section to make sure you understand that this fabric is built on an underlay which is vanilla. In the sense, it's based on standard protocols. We don't change the way the network works, okay? It's a fundamental tenet of and value proposition of Pluribus because it makes it easy to insert in existing environment. And second of all, as we discussed, we operate fundamentally on ODM switches, white box-like switches. You're familiar with some of our partners, such as Dell or D-Link or Ericsson, and we run on their hardware. So again, standard-based underlay network. And frankly, the network is the very first thing our customer want to test. If this thing doesn't recover, reconverges fast, scale at the fundamental protocol level, you're out. There's no POC deployment. The fabric is all interesting, but the network has to work in SDN. Okay, that's what we do. We pride on taking a lot of time to have a complete network stack to sustain the workloads of network operators and service providers, as well as large enterprises. Now, let's dig into the fabric. We take our underlay, right? And of course, the fabric will help you to build this underlay. But fundamentally, once the underlay is in place, it's totally transparent to the fabric. So the fabric is really, you can think of it as a distributed application. The control plane of the fabric is a distributed application that runs on top of this underlay, right? This distributed application, as I heard before, is in charge of sharing state and sharing configuration across the switches and sort of keeping them in sync with respect to configuration and state. The fabric is built on a set of secure TCP connections. So the different nodes that participate to the fabric build a mesh of TCP connection, and those connections are secure. We use TLS, SSH to communicate. But I want to notice one more time, the network underneath, they are transparent to the network underneath. The network underneath is just in charge of transporting IP. We have in-band management IP or out-of-band management IP. As long as these IPs are reachable, we can establish those communication channels. The first byproduct of this fabric is that it offers a centralized way of provisioning all the nodes in the fabric. Please, you do have a question.
Well, regardless of whether you configure this with SSH or REST API, sure. Is the endpoint a single IP address that is shared by all switches, or does each switch have an individual IP address that I can just SSH or HTTPS to any one of those?
Exactly. Very, very good question. Yes, so we don't have an Anycast IP for all the fabric.
Okay.
Every switch has its own management IP. Can be in-band, can be out-of-band, so the fabric can be formed on in-band or out-of-band, but it's a different network IP. And the beauty of this fabric is that it's a peer-to-peer architecture, in the sense that you can log into any node and you have the same perception and perspective of the fabric. Every node can control every other node. Okay? It's a truly distributed system.
Could we talk about partitioning and what happens on reconciliation?
I was just writing that question.
Before we get there, just a more basic question about the fabric control plane connection. So all those switches have to be able to talk to each other. Are you running QoS or some kind of a prioritization scheme so that they'd never lose touch?
Yeah. So of course, the fabric control plane that runs on top of this TCP connection is prioritized as the traffic going to the CPU. We have up to 64 queues built to the CPU, and we prioritize this as the BGP control plane traffic. It's as important as a BGP packet for us. So absolutely, there's a lot of control plane policing that goes into this. But let me come back to the basic of the fabric, right? So centralized management from any node. That's a concept that I think now we covered quickly. But another interesting concept is that we have the concept of fabric-wide API, REST API or CLI. So by default, when you are on this distributed system and you issue a command like show me the VLANs or show me the port statistics, you're actually hitting every node in the fabric. Then you have the ability also to specify a subgroup of the switches or even a single switch, prepending, let's say, the switch name to a command or the switch group name to a command. We can group switches within the fabric for administration convenience, if you will.
Are statistics being redistributed in advance, or they are being gathered as you ask?
On demand, as you ask. Exactly. Exactly right. This is a fundamental concept of this fabric. We don't want this to be chatty, right? And overwhelmed with control plane messages unnecessarily, right? The fabric needs to, of course, exchange configuration information, which are, let's say, an automation system driven or human driven, but it's not very chatty. And then the fabric needs to have visibility into all the endpoints connected to the fabric and share some state. But other than that, we are not blasting traffic left and right about connection, visibility, statistics across the fabric. It's a very silent protocol, very low overhead in terms of network. So the fabric-wide API is very important. The last point on this slide is atomic configuration transactions. This is actually very key, very, very key to the functioning of the fabric. What does it mean? It means that the fabric operates based on transactions. And these transactions, either they succeed across all the nodes of the fabric, or they cannot be committed. So for this, we use a protocol which is called, it's a modification, a variation of protocol called three-phase commit, invented in the 80s for database cluster and replicated systems.
That was my next question.
Yes, whose task of effectively ensuring that before a transaction or a configuration is committed across all the nodes of the fabric, all the nodes of the fabric have the resources and they've agreed to take this connection, this transaction. And everything is transaction. So when you program from your automation system through REST API, this fabric, you don't have to worry. Let me make a practical example. Let's take it down 3 notches here, right? Let's say you have to configure an ACL, and you have 20, 30, 40 switches. Through REST API, you issue one command, the fabric-wide API, and then the fabric takes care that every switch has enough ACL resources in the TCAM to commit whatever you're asking it to, right? Because ACL you may not fit in some switches, may fit in others. The fabric takes care of managing that. You as the application developer don't care about dealing with 40 switches. The fabric takes care of it. That's why the operation is atomic. Either it succeeds on the entire fabric, or you roll back.
It's a logical end operation.
Yes, exactly.
So it makes sense to have the whole fabric with similar switches, because if I have a bigger switch, I can't use that, because the limit is the smallest TCAM I have on the fabric.
Exactly.
Yeah.
If you, yes, let me say yes, but I want to qualify that. Also note that sometimes you have a different switch for the spine and a different switch for the leaf. But the policies, sometimes you want to institute these policies only on the leaf and not on the spine. So we still have the flexibility to mix and match forwarding engines and deal with sort of a diverse set of hardware capability and scale, because the network operators need this level of flexibility. So the fabric does not force you to deploy an homogeneous system, all Broadcom Trident 2 or Tomahawk. You can mix and match different ASICs, different forwarding engines and capability. But the fabric, if you're trying to deploy, let's say, 3000 ACL on a Tomahawk switch, they don't fit because I think you get 1500 or something in that range, then the fabric refuses to do that, right? And even if you have a switch that has 3000 or whatever the number is, that switch won't be able to commit that particular ACL, okay? That's an example, but I think making an example probably makes sense. That's why, anyway, this is actually a sophisticated distributed system, right? It's not just a management system.
Yeah, but I missed how you solve that. You create two fabric, one for the leaf, one for the spine, or you split the single fabric into groups?
That's one option. Or your REST API orchestration system is aware of this hardware differentiation, so you issue a command only to a subset of the nodes of the fabric.
Okay.
Okay? This is a policy that only fits these 3 leaves, for example. You distribute policies to a subset of the node.
Do you model those capabilities, or it will fail on commit?
Right.
Are you going to try them even knowing that you shouldn't be?
So sort of a dry run capability, you're asking. No, we don't have a dry run capability right now. It's something actually we're working to model the hardware resources, but because we work on such diverse hardware, it's actually kind of a complicated issue.
It is.
But I agree, dry run capability would be effective, but we don't have it right now.
Okay, so based on what I just heard,
Yes.
I'm going to guess something here, and I want you to validate whether this is right or not. So because I have this differentiation in switches, I might, in a multi-tenant environment, upgrade a certain set of the switches that are for one client or one tenant that has, say, bigger requirements, bigger ACLs, and then move the other tenants that have lesser requirements to the older set of switches that have lesser capabilities, and then use the capability you just talked about to only program the one set that has the larger ACLs.
Yes. Certainly.
Okay.
That's absolutely a possibility.
Okay.
Yes.
So you just use the fabric-wide API as an example to say, hey, I could push it to everywhere, or you could subset.
Okay.
Absolutely.
Okay.
But by default, as you log into this system, you have the entire set of resources available. For example, if you do, show me the statistics of port 5. You see port 5 across all the 20 switches. You have to be specific if you want to identify a limited set of nodes.
Okay, so now that I have this straight that I can try something and it'll roll back or fail if it doesn't succeed, is there a way that I can ask the system, other than just blindly trying it, what do you have for resources?
Yeah, this is actually what the transaction is. The fabric does this for you. Before actually something fails, nothing actually fails, because the 3-phase commit is a sort of a protocol which goes through several steps, several phases, three or more. Let's say in our case it's a little bit more than 3. But the logic is there is a coordinator node, and all the cohorts listening or participating to the transaction, they have to agree to commit to a transaction. So if you are a node that doesn't have the resources, you're not going to try and then fail and report. You're going to say, hey, my TCAM is full, example of the TCAM. Or
okay,
I
so
have
for
no
the automation,
space,
right.
Or this port doesn't exist, right? And you communicate that before there is a commit operation in the last phase of this synchronization protocol.
So for automation, your typical scenario would be try, catch an exception, or go ahead and commit.
Yeah.
Okay.
Again, you treat the fabric as an atomic system. Okay? It's like you're programming one switch. Now there are n switches. You are unaware of it. But the fabric takes care of giving you the illusion that you don't need to worry about managing exceptions on n nodes. The fabric does it for you. That's the logic. The fabric manages those exceptions through this 3-phase commit strategy.
Speaking about fabric-wide, is it one SNMP node or many SNMP nodes?
Okay, that's another beautiful question. So as much as we have n spanning tree speakers, n BGP routers, we also have n SNMP node, n syslog servers. So again, if I roll back here, this is how your network is supposed to work. We don't want to change the logic.
Okay.
You have n
So
switches.
management plane is distributed.
Yes.
Control planes are independent.
Yes, the network control plane, the layer 2, layer 3 control plane is totally independent.
Okay.
Then we bring in this, what right now you're correct. right now looks like a management plane. And then I show you how this management plane can augment some of the forwarding capabilities and forwarding logic. But absolutely, this is a very fair summary at this point.
Can we go into partitioning now?
No, man, you have to wait. I have it later. All right, so let me move to the next important concept. This is actually something which I think is kind of elegant. I mean, at least I like it. All right, so we have fabric-wide objects, right? And I'll explain why we have fabric-wide objects in a second. What are those objects? When I say objects, of course, is a metaphor, right? They're not real. But an object is a network construct. Think of it as a VLAN, a VRF, a subnet, an Anycast gateway, an ACL, a policy, even NAT. Those are capabilities which are distributed across the fabric, which means that you have to configure one VLAN or one VRF on the fabric, and then the fabric distributes the configuration of these objects underneath. You don't see it. But the beauty is that now you don't have to configure n subnets on n switches. You configure one subnet across the fabric, one VRF across the fabric. So that dramatically simplifies and reduces the number of configuration commands. And also there's a degree of built-in automation, because now that you're committing a VRF or a VLAN on 20 nodes, you do it once, and then it's automated by the fabric on the other 19 nodes.
Okay, I need a clarification here. When you say fabric-wide, are you talking about on a per tenant basis or the entire fabric?
It's all of these are on a per tenant basis.
Okay.
Because the tenant has a virtualized view of the fabric. And
okay.
Again, I know you guys love this segmentation. I get there, but I need to build it. But for now, I only have one fabric. I didn't even
just trying to fit it in.
The answer is both.
Yes. So it's at both level. If you're tenantizing your network, you can give the tenant the ability to instantiate his own VLANs, his own VRFs. Okay?
And you're using Anycast gateways on the edge switches.
It's one of the capabilities. You don't have to turn it on, but we have it, and I'm going to go through more details on that. Again, look, maybe this is obvious, maybe not, but I wanted to show an example of what is a fabric-wide object. I chose, in this case, a subnet, subnet for app10, 10.0.10/24. With one command, we have 40 switches, make the best case, 40 switches in this example, and you issue this one single command, and you're deploying this subnet and associated to the blue VRF across 40 switches. That's it. In a regular environment, you have to go into 40 separate switches and issue this command, right? So, please.
You mentioned tenants before. Does that mean that every tenant can SSH into the fabric and create his own VLANs and VRFs using these commands?
Yes, and I'll show you, and if you allow me, I'll show you what is the tenant manager in a second. It's actually pretty cool. It's one of the services that is built on top of this fabric. So, but the idea here is that one single command, the entire fabric is taken care of. Of course, we don't have every single object distributed, but we have a good variety and a good breadth at this point. Okay? I claim here in this example, 1/40 is the number of the sort of command reduction you have, right? You have 40 switches, one command, so you're saving 39 commands. Is in excess of 95% configuration savings.
So I configure a VRF across 40 different devices. However, every different device is supposed to have their own router ID and their unique semantics to every switch/VRF.
Well, these are distributed VRFs. We don't have a full routing control plane for that. This is we can go into more details of how we build VRFs, but fundamentally VRFs are very light construct.
It's a virtual router.
Yeah. Another object which is local to a switch, but is fabric-wide. Notice that I'm trying to change the language here a little bit, because here I'm talking about fabric-wide object. This is not really a fabric-wide object, because the VTEP is local to a switch, but every other switch in the fabric is aware of every other VTEPs. So you build a VTEP on leaf 1 or leaf 2, every other switch knows that there's a VTEP. And I use this capability for our auto tunnel feature, which I'm going to show you a little bit more in detail. So even VTEPs are actually objects who are made aware to all the other nodes in the fabric. vPort. vPort is another fundamental construct, and yet again, another distributed object of the fabric. What is vPort? First, let me define vPort, and then we look into the database. A vPort is a virtual port. Okay? In English, it's a virtual port. And it represents effectively a MAC address, right? Which is learned by the switches. You learn MAC address in a regular switch, you put it in a layer 2 table. We do that, of course, but we also create a representation of an endpoint or a MAC address connected to the fabric, which is called the vPort. And then we put all these vPorts, which now have a representation in our software, in a database, which we call it the vPort database, which is a logical extension of a hardware table. Logical extension in many ways. But
would it create forwarding entries on every switch, or is just control plane entity which could be downloaded if there's active flow?
Exactly. I think you hit it exactly right. We use this vPort database as effectively a way to be aware of every endpoint connected to the fabric, but only if conversations between endpoints are active, we download this vPort entry into the hardware tables.
Conversational learning.
It's like EVP.
Conversational learning.
Yeah, I call it conversational forwarding.
Yeah, whatever. So you do the same thing as Brocade did with their automatic migration of port profiles.
I'm not familiar with Brocade for profiles.
You attach a number of attributes to a MAC address.
Yes.
As the MAC address moves, the attributes move with the MAC address.
Exactly.
Who's Brocade?
Exactly. Yeah.
Oh, sorry. That other company.
The vPort database, of course, in a layer 2 table, you have the MAC address, the VLAN, the switch port information. Here we have layer 3 information associated in our representation in software. Layer 3 information like the IP address. We have where there's a virtual IP port associated, the owner of the switch in the fabric, and then we have a set of other metadata like all the vSphere information are also brought into the metadata.
So you're not mentioning, but do you eliminate MAC learning and flooding, since you know every MAC address?
Yes, we not completely. Not completely.
Sure, if it's unknown, you have to flood. But
yes, if it's unknown, yes. But think about this, and this is actually, I want to talk about this later on. It's one of the forwarding optimization we have. But let me, since you're asking, I don't want to push it too late. Because this database is persistent, vPort entries are persistent. So if the communication in a layer 2 table are pages, and you remove the entry from the switch, right? But this is persistent. So you never lose memory that somebody with that MAC address, IP address was at some point on the fabric. The very second time somebody is ARPing for this destination IP, we just reactivate the entry in hardware. So effectively we suppress broadcast because the entry is already in our database system. The packet goes to the CPU, right? And we use the switch to reactivate immediately the entry in hardware. We don't necessarily have to flood all around.
Does that mean that you're doing proxy ARP? Or
Yes, we do exactly proxy ARP, yes.
so does it
Proxy
mean
ARP or turning broadcast into unicast?
No, proxy ARP at, we do
At the ingress switch?
yes.
if you use VXLAN, would you also have association with remote VTEP?
Yes. Yes.
Pretty cool.
We also do it conversationally, of course, over a layer 3 network where we have VXLAN. Yeah, similarly to other options. Okay, this is an important concept, right? So vPort is fundamental to the way we actually do forwarding, right? It helps a lot with the forwarding as well as visibility in the fabric. The way I like to summarize the vPort database is the distributed endpoint directory and switching activity history book of the Pluribus fabric. That's really what it does. You never lose memory and site, you track migrations of endpoints, and it allows you to perform, say, ARP suppression, right? And things of along the lines of optimizing forwarding, which I'm going to talk about in a moment.
IPv6?
Yeah, IPv6 is one of the underlay options we have, IPv4 and IPv6.
And the suppression together with ARP suppression?
Yeah, that's
Yes.
next question.
Yes.
Okay.
Exactly.
Does
Exactly.
this suggest that unicast flooding is not a problem in this architecture?
Unicast, for unknown unicast? Yeah, so unknown unicast, we deal also with unknown unicast traffic, but the very first time, when the vPort has never been in the database, nobody knows about, the very first time we rely on flood and learn for that.
So you're flooding the unknown unknowns.
Yes. But once, yes, exactly.
So watch out for those known unknowns.
I think that's a good,
Right, the
that's a good
unknown
summary.
knowns.
That's actually a good summary. Yes. All right. Now, I want to spend maybe a couple of slides on how can you form the fabric. There was this question, but I think it's a very pertinent question. The first question the customer wants to understand: what are my options here to build this fabric? What do I need? Well, we are finding that a lot of customers gravitate towards the option of, I already have my management network. I want to build this fabric on the out-of-band management port. Okay? Other customers say, you know what? This fabric is critical. There's only one management port on the switch. I am paranoid. If that management port goes down, I need the high availability. So can I use the intrinsic high availability multipathing of the network to ensure that this control plane has a highly available underlay? So we can also run the fabric in band, right? Whether the network is layer 2 or whether the network is layer 3, right?
If I recall correctly, somewhere in previous slide, it was secure TCP over VXLAN. Is it correct?
No, not over VXLAN.
It's over IP.
Just a secure over IP.
Okay.
Yes. Yeah. No VXLAN. VXLAN is to transport customer traffic.
You never know.
The network traffic. We don't use this for our control plane. The interesting part is that because it's over IP, now I can extend this fabric across multiple pods and across IP boundaries, right? So it doesn't have to be contiguous like a leaf and spine, right? These nodes, this is just one topology, but they can really be anywhere. Really, they can be anywhere. 2 nodes here, 2 nodes in San Francisco, 2 nodes in Santa Clara, and you can build this logical fabric. Because again, it's a distributed application that operates over IP. Now, this is sort of closes some of the high-level introduction on the fabric. But I wanted to sort of revisit some of the technical properties we discussed and highlight the value. What value are they enabling? So number one, it's a distributed application on top of a standard underlay. What are the consequences of having this technical capability? Number one, standard underlay means I can sit into any network, fit into any network, right? A lot of networking is about fitting into the existing environment. And yes, we hit that, right? Second, because we are an application, so we operate at a higher level of the OSI stack, we're not bound with our control plane to a particular location. This is the point we just discussed. As long as you can transport IP, I can sit anywhere. I can put my nodes anywhere. And also, as a consequence, or of course, as an extension of this concept, I'm also topologically independent. I don't dictate or mandate a leaf and spine design or a certain topology. Okay? You're just building an application relationship between the switch nodes that participate to what we call a fabric. But notice this fabric, although we call it a fabric, unlike traditional networking fabric, we don't touch the control plane of the network from a protocol standpoint. We don't introduce a new protocol. And we don't require any special custom hardware. We just need a network or an underlay that is capable of giving me IP reachability between my management IPs. Second, you have seen that we have the centralized operation, the fabric-wide API. We discussed the atomic transaction, the fabric-wide objects. These three concepts make it actually a pretty good environment if you want to really have something efficient and simple to operate. Distributed objects, in one shot, you address and switches to provision standard construct of VRF and Anycast gateway and things of this nature. And then the fabric takes care of making sure that all these transactions succeed at scale across the entire fabric. So you, as an operator, don't have to deal, oh, I have 3 switches that are offline, this doesn't work, this power supply, we ran out of resources on this switch. The fabric is such that it never runs out of sync because it's based on these transactions. Then we have the vPort concept. vPort is instrumental to optimize forwarding. We had a discussion on the proxy ARP, for example. But also vPort is very important, and this is what we're going to show you later. It shows you how we can use it to augment the overlay control plane. The VTEP awareness, the point I was making before, is going to come back in a couple of minutes. And then, of course, last but not least, I want to point out that we are doing all this based on open networking switches. Okay? Yeah, you can source the hardware from Pluribus. We have our option. But you're welcome to actually source it through our open networking partners.